Hey everyone, today we are going to solve the Daily LeetCode challenge of 8th April 2024 and the problem statement is number of students unable to eat lunch. So let us first understand the problem statement. So according to the problem statement, we have been given two integer arrays, students and sandwiches, such that both of them contain only zeros and ones, okay? Such that this zero represent a circular sandwich and one represent a square sandwich, fine? Now what does each of the elements of this student represent? So each of the elements represent the type of the sandwich which is wanted by this child. So if we have this 0th child, so he wants the square sandwich because one represents a square sandwich. Similarly, this child at the first index wants a square sandwich. The student at the second index wants a circular sandwich and the student at the third index wants a circular sandwich as well. Now all these students are standing in a queue, okay? So a queue is something like in which we stand in a school canteen or in a college canteen as well. So it means that the one who will come first would be served first, correct? That is, it follows P4. That is first in, first out. So whosoever would come first in the line would be given their order first, and the one who would be at the last would be served their order at the last, okay? Now, what are these sandwiches? So these sandwiches are put on in a stack. So let's say, what does this represent? It means that at the end of the stack, we have 1. Then after that, we have this 0. Then we have this 1. And then we have this 0. So at the top of the stack, we have a 0. So it means that at the top of the stack, we have a circular sandwich. Okay. Now, according to the problem statement, what does it mention that if these students are standing in a queue? So let me write this over here. So if this particular child wants a square sandwich and we have a square sandwich at the top. So what will happen? This child will get the square sandwich and he will come out of the line. Because say for example, we are standing in a queue or in a line in our canteen and we want our order. So whenever our order gets served, what we do? We come out of the line, right? Because our order have been served. So whenever he'll get his desired sandwich, what he'll do is he'll come out of the line. And what if that this particular child wants a square sandwich, but at the top of the stack, what is it present? It's a circular sandwich. So this child doesn't want a circular sandwich. So what he will do is he will go at the end of the line. So this child will go at the end of this queue. Okay. Then we will check whether this child wants the top value. So we can see that this child wants a square sandwich as well, but we have a circular sandwich at the top. So what it will happen? This child will also move at the end. So this child will come over here. Now, which child do we have over here? Now, this child wants a circular sandwich. And what do we have at the top? At the top, we have a circular sandwich. So, what we will do? This child will get his order. So, he will come out of the line. So, let's remove this child from here. Okay. And since he has taken this circular sandwich, so what we will do? We will remove it from the stack. Fine. Now, what is in the top of our stack? In the top of the stack, we have this square sandwich. Now we are at this child. Now we will say that does this child want a square sandwich? So we can see that this child wants a circular sandwich. So what will happen? He will go at the end of this queue. So he will go at the end of the line. Now what do we have? We have this child again at the front of the line. Now what does this child want? This child wants a square sandwich and we have a square sandwich at the top. So what will happen? This child's order will get served and he will get this square sandwich. So since this square sandwich was taken by this child, so we will remove it from the stack. Now at the top of the stack, we have a circular sandwich. Okay. Now we are left with these two children. Fine. Now what does this child want? This child wants a square sandwich. But do we have a square sandwich at the top? No. So what will happen? This child will reach at the end again. Okay. Now we will see that this is the child at the front. And what sandwich does he want? He wants a circular sandwich. So since at the top we have a circular sandwich, what will happen? His order will get served. And this circular sandwich, we will remove it because this circular sandwich was given to this particular child. Fine. Now we have only one child who wants a square sandwich. And what is at the top of the stack? At the top of the stack, we have a square sandwich. So we will give this child his order and we will remove this. Okay. Now we can see that our stack is empty. So what does it mean? It means that all the sandwiches have been consumed by all the students. So how many children were unable to eat their lunch? None of them. Correct? Because we can see that each of the child got their order. So none of them were unable to eat, right? So the answer to this particular test case would be 0 because everyone got their orders, right? Now, there are two things to notice in this problem. The first thing is if at the top of the stack, we have a sandwich which is wanted by the child, correct? Let's say we have a 0 over here and we have a 1 over here, correct? And let's say that this is the preference of the child, okay? So what does the first child want? The first child wants a square sandwich, But what is at the top of the stack? At the top of the stack, we have a circular sandwich. So can he get this sandwich? No. So what he will do, he will go at the end of the queue. So he will come over here and we will move at this. So we will see that this student wants a circular sandwich. And what is at the top? At the top, we have a circular sandwich only. So what will happen? This student will get his order and we will remove this sandwich. Why? Because this sandwich was taken by this child, correct? Now we will reach at this child. And what is at the top? At the top, we have a square sandwich and this child wants a square sandwich. So what will happen? This child will get his square sandwich and we can see that both of these child was able to eat their lunch, correct? Because both of them got their preferred order, correct? So what is the first case? In the first case, what we will have? We will have that every student gets the sandwich that they want, correct? So if every student will get the sandwich which they want, then none of them would be unable to eat, right? Because everyone would eat something, right? Because they would get the order which they wanted. Now what would be the second case? So let's say we have two students such that the first student want a square sandwich and the second student also want a square sandwich, correct? But what do we have in our stack? In our stack, we have the circular sandwich at the top and a square sandwich at the bottom, okay? So we will come at this child and we will say that this child wants a square sandwich, but at the top we have a circular sandwich. So what we will do, this child will go at the end of the queue, that is he will come over here and we will now process the order of this child. So what we can see that this child also wants a square sandwich, but at the top what do we have? We have a circular sandwich. So what will happen? This child will go at the end of the queue, correct? Now you can see that we are back to the same child, correct? This was the only child whom we sent at the end, right? So what did we notice over here? We noticed that if there is no student who want the element which is present at the top, that is, if there is no student who wants the sandwich which is present at the top of the stack, then none of the students after it would be able to eat anything, correct? Because how stack works, first we have to remove this, then only we will be able to remove this, right? So first of all, we'll have to give this circular sandwich to someone, then only we'll be able to give this square sandwich to someone, right? But if there is no one who wants a circular sandwich, so in the problem statement it's mentioned that until and unless no one wants it, we can't remove it, right? So if no one wants a circular sandwich, we can't remove it. So if no one will want the top sandwich, then none of them will able to eat, right? So what is the second case? If no one wants to eat top sandwich, then what will happen? Then everyone won't be able to eat. That is, everyone would be unable to eat anything, correct? Because if no one wants this element which is at the top, then we won't be able to remove it, correct? And if we won't be able to remove it, then we won't be able to distribute any of the elements which is below it, right? Which is after it. So the second case would be if no one wants to eat the top sandwich, then everyone won't be able to eat anything, okay? So what did we discuss? So we discussed that first case is that everyone gets to eat the sandwich, right? That is, no one would be unable to eat. And how it could be possible? It is if we have preferences of child like 0, 1 and in the stack we have something like 1, 0. So we can see that this child wants a circular sandwich, but we have a square sandwich. So what will happen? Child will go at the end and we would be here. And this child wants a square sandwich. So what will happen? We will give this child the square sandwich. And now the top value is this. And this child wants a circular sandwich. So we'll give this child the circular sandwich. And we can see that both the child were able to eat their preferred sandwich, correct? So the first case would be that everyone gets to eat the sandwich. And when it could be possible? It could be possible when there exists a child who wants to eat the top element, correct? So whenever that particular statement holds true, that is when there always exists a child who wants to eat the element present at the top, that is the sandwich present at the top, then everyone would be able to eat, right? But what is the second case? The second case could be that if no one wants to eat the top sandwich, correct? Then all the remaining student would be unable to eat. Like if we can have a circular sandwich over here and a square sandwich over here, but the preferences of both the child is a square sandwich. So we can see that none of them wants a circular sandwich, right? So since none of them wants a circular sandwich, so we won't be able to remove this circular sandwich from here, because we can remove this circular sandwich from here only when someone wants it, correct? So when someone wants it, then only we'll be able to assign it to him and we'll be remove it from here, right? But we can see that no one wants a circular sandwich, so it will always remain at the top. So no one would be able to eat any of the sandwiches after that, correct? So in this example, both the students won't be able to eat their lunch, okay? So let's see how we can solve this problem. So we understood one thing over here, that is we need to keep track of that which student want which sandwich, correct? So we can say that if we have a variable like wants circular in which we will store the count of the students who wants a circular sandwich, correct? And similarly, we can have another variable called want square that will represent the count of student who wants a square sandwich. So in this example, we can see that how many student wants a circular sandwich. So there are no students who wants a circular sandwich, so it will remain as 0. And what is the count of student who wants a square sandwich? We can see that there are 2 students who wants a square sandwich. So what would be its count? Its count would be 2, correct? Now, once we have calculated that how many students wants a circular sandwich and how many students wants a square sandwich, what we can do is we can iterate over this sandwiches array. So in this case, what is our sandwiches array? Our sandwiches array would be this 0, 1 such that this 0 represent the top element of the stack, correct? So what we will do is we will iterate over this sandwiches array and we will check that what is the sandwich present at the top of our stack. It's 0, that correct? That is a circular sandwich. Now we will check that does there exist a child who wants a circular sandwich. So we can see that the count of children who wants a circular sandwich is 0. So what does it mean? It means that none of the child wants a circular sandwich. So if no child wants a circular sandwich, so we won't be able to take it out of the stack. And since we won't be able to take it out of the stack, so what does it mean? It means that all the students won't be able to eat anything. Why? Because only if we can remove this, then only we can give this square sandwich to someone, right? But since no one wants this circular sandwich, so we can't remove it. And if we can't remove it, we can't assign any sandwiches which would be present after it to anyone, correct? So whenever we see that this is the top element and the count of the student who want the top element is 0. So what does it mean? It means that no one wants it and we can't remove it. So it means that all these 2 students, that is all the 2 students who want a square sandwich won't be able to get their square sandwich, correct? So what would be the answer to this particular test case? It would be 2, because we can see that both these children won't be able to eat their lunch because we won't be able to take this 0 out of it, correct? And since we can't take this 0 out of this stack, we won't be able to give this particular square sandwich to anyone, correct? What we are going to do is we are going to take 2 variables, one circular and one square. And what we will do, initially both would be 0, and we will use this one circular in order to calculate that how many students wants a circular sandwich. And we will use this one square in order to count that how many students want a square sandwich. And we will iterate over this sandwich array. And if we will see that this is the top element, correct? And if no one wants the top element, then what does it mean? It means that we won't be able to remove this top element. And since we won't be able to remove this top element, then what does it mean? It means that all the remaining students won't be able to eat their lunch because we can't remove this, right? So all these sandwiches which would be present after it, we won't be able to assign it to anyone, correct? So let's quickly do a dry run over this test case, okay? So let us first find out that how many students wants a circular sandwich. So we can see that in this particular students array, there are 2 students who wants a circular sandwich. So what would be the count of one circular? It would be 2, correct? And let's find out how many students wants a square sandwich. So we can see over here that what is the count of square sandwich? It's 1, 2, 3, 4. That is, there are 4 students who wants a square sandwich, correct? Now, once we have calculated that how many students wants a circular sandwich and how many students wants a square sandwich, what we will do is we will iterate over this sandwiches array. So we have 1, 0, 0, 0, 1, 1, correct? So we are present over here. That is, this element is present at the top of the stack, correct? So what we will do, this is a square sandwich, correct? So we will check that is there a student who wants a square sandwich? So we can see that the count of square sandwich is not 0. So what does it imply? It implies that there exists some children or a child who wants a square sandwich. So since there exists a child who wants a square sandwich, so what we will do is, we will assign this square sandwich to a child, correct? And we will move forward to the next sandwich. And since we have assigned this sandwich to a child, so what we will do, we will subtract 1 from here. Why are we subtracting 1 from here? Because one of these 4 students got a square sandwich, correct? That is, his order was processed, so we will be subtracting 1. So what we will get? We will get 3. Now we are over here. Now what is at the top of the stack? At the top of the stack, we have a circular sandwich. Now we will check. Does any child exist who wants a circular sandwich? So we can see that the count of want circular is not 0. Correct. So what does it mean? It means that there exists some student who wants a circular sandwich. Correct. And since there exists some student who wants a circular sandwich, what we will do is we will assign this sandwich to a child. Correct. And since we have assigned this sandwich to a child, what we will do, we'll subtract 1 from here and we will get 1. Correct? Because one of the child got this circular sandwich, right? That's why we are subtracting 1 from here. And what we will do, we'll move forward. Correct? Now again, we are at the circular sandwich. So what we will do, we'll check that does any child wants a circular sandwich? So we can see that the count of want circular is not 0. Correct? And since this is not 0, what does it imply? It implies that there exists a child who wants a circular sandwich. So what does it mean? Since this child wants a circular sandwich, we'll give him the circular sandwich. So we'll subtract 1 from here because this child got his order and we'll get a 0. And since this sandwich was assigned to a child, so what we'll do, we'll move forward. Now again, we are at a circular sandwich. Now we will check, does there exist a child who wants a circular sandwich? So we can see that the count of one circular is 0. So what does it imply? It implies that no child wants a circular sandwich. Correct. And if no child wants a circular sandwich, then what does it mean? Now, at this moment, what do we have in our stack? We have this 0, 1, 1. Correct? That is 0 at the top. Then we have a 1. Then we have a 1. And what we notice? We notice that the circular count is 0. So what does it mean? It means that no child wants this circular sandwich. And since no child wants this circular sandwich, we can't take it out of the stack. Correct? And since we can't take it out of the stack, so what does it mean? It means that these 3 children who wants a square sandwich won't be able to get this square sandwich. Why? Because these 2 square sandwiches are present after this circular sandwich. Correct? And since we won't be able to remove this circular sandwich because no one wants a circular sandwich, so we won't be able to assign these 2 square sandwiches to anyone. Correct? So whenever we'll find out that a particular sandwich is wanted, but the count of the student who want that sandwich is 0, then what does it mean? It means that we can't take that sandwich out of the stack. So it simply means that we won't be able to assign any of the sandwiches which would be present after it. Correct? So what would be our answer in this case? Our answer would be 3. Why? Because these are the 3 students who wants a square sandwich. But since we are not able to take this circular sandwich out of the stack, so we won't be able to process the order of these 3 children, right? So the answer to this problem would be 3, because since we won't be able to assign this circular sandwich to any of the child, so we won't be able to move forward to assign these to any of them, right? Because we can't move forward until and unless we have assigned this particular sandwich to anyone. So it simply means that these 3 students won't be able to eat their lunch, and the answer to this would be 3. Correct? Now I hope the solution is clear to you all, that what we are doing, we are first finding out the count of the student who wants a circular sandwich and the count of the students who wants a square sandwich. And what we will do after that? After that, we'll iterate over this sandwiches array and we will check that what is the top element. The top element, if the top element is a square sandwich, so we will check that does there exist a child who wants a square sandwich. So if there exists a child who wants a square sandwich, so what we will do, we'll assign this sandwich to that child and we will decrement the frequency by 1. Why? Because one child was given his order, right? So that's why we will decrement the frequency by 1. But what could be the other case? The other case could be that at the top we have a square sandwich, but the count of the student who wants square sandwich is 0. So what does it mean? It means that no one wants a square sandwich, but at the top we have a square sandwich. So it simply means that we won't be able to remove this square sandwich from the top. And since we won't be able to remove this square sandwich from the top, so what it means? It means that we won't be able to distribute any of the sandwiches after it to any child, right? So it means that all the remaining child won't be able to eat their lunch, correct? So this is what we are doing. So now that we have done this dry run for the second case in which no one wants the top element, correct? Now let's do a dry run for the first case in which everyone gets the sandwiches which they want. So let's take this as our example. So what do we have to do now? We have to first find out the count of student who wants a circular sandwich and the count of student who wants square sandwiches, correct? So in this students array, we can see that how many student wants a circular sandwich. We can see that there are 2 students who want circular sandwich. So what would be the count? The count would be 2 over here. And how many students want square sandwich? So we can see that there are 2 students who want square sandwich. So the count would be 2 over here, correct? Now, once we have calculated the count of students who want circular sandwich and square sandwich, what we have to do? We have to iterate over this sandwiches array, correct? So this is the sandwiches array and we are present at the first element. Now, what is the first element? The first element is 0. So what does it mean? It means that this 0 is present at the top of our stack. So we will check that is there exists a child who wants this circular sandwich. So we can see that the count of students wanting circular sandwich is not 0. So what does it mean? It means that there exists a child who wants a circular sandwich. So since a child wants a circular sandwich, what we will do? We will assign a circular sandwich to him. And this will get decremented by 1. Why are we subtracting 1? Because we assigned circular sandwich to him, correct? And since we assigned this circular sandwich, so what we will do? We'll move forward. Fine. Now, what do we have? We have a square sandwich at the top of the stack. Now, we will check whether there exists a student who wants a square sandwich. So, we can see that the count of student wanting a square sandwich is not 0. So, it means that there exists a child who wants a square sandwich. So what we will do is we will assign this square sandwich to a child. And since we have assigned it to a child, what we will do, we'll subtract 1 and we'll get 1. And since we have assigned this sandwich, what we will do, we'll move forward. Now at the top, we have a circular sandwich. Now we'll check, does there exist a child who wants a circular sandwich? So we can see that the count of students wanting a circular sandwich is not 0. So what does it mean? It means that there exists a student who wants a circular sandwich. So we will assign this circular sandwich to him. Correct? And we will get a 0 over here. And since we assigned this sandwich, we will move forward. Now we have a square sandwich. So we'll check that does there exist a child who wants a square sandwich? So we can see that the count of students wanting square sandwich is not 0. So what does it mean? It means that there exists a child who wants a square sandwich. So what we will do? We will assign this square sandwich to him and we will move forward. So we can see that we have processed all the elements of this sandwiches array. Correct? So since we have processed all the elements, what does it mean? It means that all the sandwiches were assigned. Correct? So since we have assigned all the sandwiches, so what does it mean? It means that every student were able to eat the lunch, correct? So what would be the answer to this problem? The answer would be 0, indicating that there were no students who were unable to eat their lunch, correct? Now I hope the solution is clear to you all. So let's quickly code this. So initially we have to take two variables, wants circular, in which we will count the number of students who wants the circular sandwich, and another variable, wants square, in which we will store the count of the students who wants a square sandwich, correct? Now, initially, what is our first step? Our first step is to iterate over the students array in order to calculate that how many students wants a circular sandwich and how many students wants a square sandwich. So let's do this. For auto, current is to students. We will say that if current equals to 0. So what does it mean? It means that the current sandwich is a circular sandwich. So what we will do? We will increment one circular count. So we will say one circular plus plus. Else what could be possible? Else it could be possible that the current sandwich is a square sandwich. So what we will do? We will simply increment one square sandwich count, correct? That is one square, correct? Now once we have populated the count of student who wants circular sandwich and the count of student who wants a square sandwich, what do we have to do? We have to iterate over this sandwiches array, correct? So we will say for auto, current is to sandwiches. Now if our current sandwich is a circular sandwich, so what do we have to check? If our current sandwich is a circular sandwich, so we have to first check if our want circular count is 0 or not. Correct? Because if our want circular count is 0, then what does it mean? It means that no one wants a circular sandwich, correct? But what do we have at the top of the stack? At the top of the stack, currently we are having a circular sandwich and no one wants a circular sandwich. So since no one wants a circular sandwich, so what does it mean? It means that we won't be able to remove this circular sandwich from the top of the stack, and since we won't be able to remove it from the top of the stack, so it simply means that all the remaining students won't be able to eat anything, correct? Because if we won't be able to remove this circular sandwich, so we can't distribute any sandwiches which would be after it, correct? So what we will return is, we will return one square. And why are we returning one square? Because these are the students who wanted the square sandwich, correct? But they won't be able to get a square sandwich because at the top we have a circular sandwich and no one wants this circular sandwich. And since we won't be able to remove it, so all the students who wants a square sandwich won't get the square sandwich, correct? Else what could be possible? Else it could be possible that this want circular count is not 0. So what does it mean? It means that the top element is a circular sandwich and the student count who wants a circular sandwich is not 0. So if it is not 0, what does it mean? It means that there exists a child who wants a circular sandwich. So what we will do? We will assign a circular sandwich to him and we will decrement the count. Why are we decrementing the count? We are decrementing the count by 1 because we have assigned a student by a circular sandwich, correct? Now else what we could have? Else we could have that at the top of the stack we are having a square sandwich, correct? So what could be the else case? Else case could be that our current is 1, that is at the top we have a square sandwich. So what do we want to check? We first want to check that is there a student who wants a square sandwich. So if there is no student who wants a square sandwich, then what does it mean? It means that at the top of the stack we have a square sandwich, but no one wants a square sandwich. So it simply means that we won't be able to distribute any of the sandwiches after that sandwich because since no one wants that sandwich, so we won't be able to take it out. And if we won't be able to take it out, so we won't be able to distribute any of the remaining sandwiches, correct? So what we will return? We will return one circular. Now, why are we returning one circular? We are returning one circular because all these students wanted a circular sandwich, but they won't be able to get the circular sandwich because at the top we have a square sandwich and no one wants a square sandwich, correct? So all the remaining students who wanted a circular sandwich won't be able to get it, correct? Now else what could be the case? The else case could be that the top element of our stack is a square sandwich and we have students who want a square sandwich. And since there exists a student who wants a square sandwich, what we will do? We will assign square sandwich to them by decrementing the want square count by 1. Correct? Because he wanted a square sandwich, so we will assign him a square sandwich. And since that particular child got his order processed, so that's why we are decrementing it by 1. Correct? Now, after that, what we will do? If we want return from here and we want return from here, then what does it mean? It simply means that all the child were able to get their order, correct? That is, all the child were able to eat something at lunch, correct? So from here, we'll simply return 0. So let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity, if we consider the size of the given array as n, then the total time complexity is order of n. Let's see how. So what we are doing over here? Here we are first iterating over the entire students array in order to calculate that how many students wants a circular sandwich and how many students wants a square sandwich. So it means that over here we will be processing all the n elements of the students array. So it will cost us a time complexity of order of n, correct? Now what are we doing over here? Over here we are iterating over the sandwiches array. So it means that over here, we would be processing all the n elements, correct, in the worst case. And what would be the worst case? The worst case would be that all students eat their lunch, correct? Because then only we would be iterating over all the elements of the sandwiches. So this will also cost us order of n time complexity. So order of n plus order of n will give us order of 2n. Since 2 is the constant, we can ignore it and we'll get order of n as the time complexity, correct? And we can see that we are not using any extra space from our end. So the space complexity would be order of 1. So that's all about today's daily LeetCode challenge. Thank you.